Let's have a look. This is to support the previous video. Um, now here, when we set the angle of twist at A, that should be equal to angle of twist of this bar, angle of twist because of that one, and angle of twist because of the hollow one, and the angle of twist at the end, which was the solid rigid. That will have an angle of twist of 0, so we can ignore that one. Now to find the angle of twist at A, B, and AB, BC, and CD, we do angle of twist at A, so AB. So the formula is TL over JG. Now the T, the torque, is 880 Newton meters. So it's meters. Best to convert into millimeters. So you got 800 Newton meters, then millimeters, 3 more zeros. So hence we got this value here. Now the length from here to here, the length of the AB is 400. So hence we got a 400 here instead of length. Now J, the diameter for that one, or the radius was that one, was 18. So if I want to find the J value was given as pi over 2 r to the power 4, and radius was 18 millimeters. So I just put 18 there, and then we got the G. The G value, if we go back in the question, the G value is 27 gigapascal. So that is 27 gigapascal. They convert 27 gigapascal into 27 with a 3 more zeros and make it megapascals. The reason they did that in megapascal is because later on the Newton per millimeter square, Newton over millimeter square, is going to be another megapascal on the top. So they will cancel up. Hence we want in megapascal. We did the same for the second part. T is on the second part. We calculated the T, which is here 2400, and I put that value 2400, but again that was Newton meters. 3 more zeros, make it millimeter. And the length for the second part was 375 millimeter, and the radius for that one was 30. So pi over 2 r to the power 4 will give me that one, and that's a different material. So if we go back, it says it's brass and the G is 39 gigapascal. So 39, 3 zeros, 39, 3 zeros, and megapascal. And then the other one was the last bit. If you remember, the last bit here is a hollow, and the hollow has the inner diameter of 40, the outer diameter is 60. So the inner radius is 20, the outer radius is 30. So I'm just going to do the formula here. The formula for the J for a hollow bar is pi over 2 bracket r outer square minus r inner square. I put the uppercase r, does not matter. Outer radius is 30, the inner radius is 20. Oh, sorry, it is not square, it is to the power 4 because we're finding the second moment of area, not the first. 4 and 4, and that will give you the value of the J. And then I got is brass, 39 mega, 39000, make it megapascal, and the length for the last part was 250. I will put all these things together in our calculator. When I put that one, it will give me an answer in radian, 0.105 radian. How do I convert from radians to degree? There is a direct conversion, but if you don't know, 1 radian is equal to Control Z, 360 degree equals to 2 pi radian. Yeah. So 1 radian is equal to 360 divided by 2 pi, yeah, which will give you an answer of around 53, 57. Let's do 360 divided by 2 times a pi, 57.3, yeah. So 1 radian is 57.3 degree. So if you want to convert that one, you got 0.105 radian. You multiply this thing by 57.03, and that will give you an answer in degree, which is 6 degrees. So there is a twist of 6 degrees. So that is 57.3, not 57.03. Yeah, so 57.3, and that will give you 6.02 degrees.